Hello everyone, I am Ashok. Welcome to the new video. In this video, we discussing about KCL and significance and sign convention and two gate question regarding KCL. You are not subscribed to my channel, please subscribe to my channel and press the bell icon, get notified as soon as possible when you upload the new video. Let's move on to the question. What is the full form of KCL? Kirchhoff current law. How can you define in an electrical network the algebraic sum of current met at the node is 0, or at any junction sum of current entering the junction is equal to sum of current leaving the junction? What is the significance of this law? This law signifies the law of conservation of charge. What is the sign convention of this law? And when we put positive and when we put negative, current entering the node are taken as positive and current leaving the node are taken as negative. But in case we take negative also and positive also, I will prove it. I will take one example, this circuit, and this node I call it as A. I will consider I1, this is I2, this is I3, this is leaving the node I3, this is I4, this is I5. This may be written as entering the node is positive I1 plus I2 plus I3, leaving the node is negative, so you put negative sign, I4 minus I5 is equal to 0. I will prove when entering the node are taken as positive and leaving the node is negative, but I take positive. I will prove how it is. I will take another node. This is I1, this is I2, this is I3, this is I5, this is I4, this is I4. I will prove entering the node is negative. I will take entering the node is negative, minus I1 minus I2 minus I3, entering the node is positive, plus I4 plus I5 is equal to 0. Compare both equation. I will take negative common sign, I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. I will pass negative sign to right hand side. I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. These equations are both are same, so we'll consider as leaving the node is one side and entering the node one side will get equal, so we will get both are equal. It is a short trick of this video. I will consider one resistance and one side is V1 potential, another side is V2 potential. How to calculate current I? I will find out I is equal to V by R. We know that according to Ohm's law. So we consider I is equal to, this is R, V1 higher potential minus lower potential divided by R. This is the formula to calculate I. Let's move on to the problem. This is one of the previous year gate question. It is seems like a difficulty, but it is very easy. But is it very tricky? How can you find out this? First, you find out I1, I2, I3, and I4. This is I1, this is I2, this is I3, and this is I4. How will you find out? First, we apply KCL at the node A. We find out I4. Second, apply KCL at B. We get I1. And KCL at C, we get I2. So let's move. KCL at the node A. By the definition, entering the current is equal to leaving the current at the node. I will consider I4 is entering. I4, these are all leaving. So is equal to 6 plus 8. I4 is equal to 6 plus 8 is 14 ampere. I will get I4 is equal to 14 ampere. Then you apply KCL at B. Enter in the node is 8 and these both are leaving the node is equal to 7 plus I1. 8 minus 7 is equal to I1. 8 minus 7 is 1 is equal to I1. I1 is equal to 1 ampere. Then we apply KCL at C node. This is C node. This is entering. This is leaving. This is leaving. I1 is equal to, this is leaving, I2 plus 5 ampere. I1 is 1 ampere. 1 is equal to I2 plus 5 ampere. 1 minus 5 is equal to I2. I2 is equal to minus 4 ampere. This is my answer. I will check. 8 ampere, this from this side, it will divide into 7 ampere and this is 1 ampere. This is true. Then I will move on to this node. This is 1 ampere. This is 5 ampere. This is minus 4 ampere. This will also true. Minus 4. In this 5 minus 4 is 1. This is true. Then we move on to this I3. Apply KCL at D. This is entering, this is entering, this is leaving. Leaving is I4 is equal to I3 plus 5 ampere. I4 is 14. 14 is equal to I3 plus 5. 14 minus 5 is equal to I3. I3 is equal to 9 ampere. I will check. I3 is 9 ampere. 9 ampere. This is also 5 ampere. 9 plus 5 is 14. This is also true. So my answer is true. This way you check your answer. I will move on to the next question. This is also previous gate question. It is very tricky and very simple question. I will tell the trick of this question. We find out I1, I2, I3 and V. We first find out V, then we calculate I1, I2, I3 easily. This is V, this is I1, this is I2, this is I3. I will first ground this circuit. I will consider as V2. This is our same. I will consider this. V2 is equal to V1. V1 is equal to V2. I will first apply KCL at this node. This is I1. This is entering. Entering means minus 10. This is leaving plus I2. This is also leaving plus 2. This is also leaving plus 3. I3 is equal to 0. I will put instead of I1 V1 minus V2 by R. I will previously said that this is resistor, this is potential V1, this is potential V2, this is lower potential, this is higher potential, this is R, and I am passing through this resistance. How can you find out I? I is equal to higher potential minus lower potential divided by resistance. So same as that of I will find out same. R is equal to 2 minus 10 ampere plus I2. I2 is considered replaced by V1 minus V2 divided by 5 plus 2 plus I3 is replaced by V1 minus V2 divided by 10 is equal to 0. In this I will grounded that V2 is equal to 0. I will consider V1 is equal to V. So this is also 0, this is also 0, this is also 0. V1 is considered as V. V by 2 minus 10 plus V by 5 plus 2 plus V by 10 is equal to 0. 10 minus 2 is 8, minus 8, this side will go this side, plus 8, V by 2 plus V by 5 plus V by 10 is equal to 8. I take V common from both of these. 1 by 2 plus 1 by 5 plus 1 by 10 is equal to 8. I take both of these LCM. 7 by 5 1 is 5 plus 2 is 7. 7 by 10 plus 1 by 10 is equal to 8. V of 7 bases are same. 7 plus 1 is 8. 8 by 10 is equal to 8. This 8 cancel. V is equal to 10. We find out I1, I2, I3. I1 is equal to this. I2 is equal to this. I3 is equal to this. This. I3 is equal to this. We'll find out I1 is equal to V by 2. This is resistance 2. So I1 is equal to V is 10. 10 by 2 is 5 ampere. I2 is equal to V1 by 5. This is 5. V is 10 by 5 is equal to 10 by 5 ones are 2 ampere. I3 is equal to V by 10. V is 10. 10 by 10 is equal to 1 ampere. This is also check. This is 10 ampere. Leaving this 2 ampere. This is I1 is equal to 5 ampere. I2 is equal to 2 ampere. Is 1 ampere. This 10 ampere. This will 10 ampere. This is 10 ampere. 5 ampere. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2, 1 is 10. So we'll prove that the entering the node is 10 ampere and leaving the node is 10 ampere. So this problem is true. Thank you for watching till